Decision Theory Part 4, Decision Trees. Okay, so we've worked with decision making with probabilities and expected value without perfect information, expected value with perfect information, and expected value of perfect information. And we used the payoff tables. Now we're going to be using decision trees. And it's going to have the same information. It's just going to kind of be written out a little bit more and in chronological order. So it's the same process, a lot of the same information, but just a different view of the probabilities. So nothing to be worried about here. It's something that we can totally do and that you've seen before from the other video, but just going to be a different perspective. And here's really the most important part, is the decision node. When you see a square decision node, a square icon like that, that means you need to make a decision. When you see a circular decision, a circular node or a circular icon, it's a state of nature node, which means you have to make a calculation. Those are very key points. This will make it so much easier for you. If you can remember, the squares when you make a decision, and the circle is when you make a calculation, when you create an expected value. Okay, let's keep going here. Okay, so decision, and again, you can go through the slides and review the tape, and you have the slides on your own. So if you want to write this information down or maybe reread it a few different times, that's always a good idea. But we'll go on to the question here, or more through the slides and then get to the questions. Okay, so decision tree example, no sample information. Consider the following problem with 3 decision alternatives and 2 states of nature with a payoff table. So this is how we found the expected value without perfect information before, right? That was the payoff table. We had our decision alternatives, we had our states of nature, and these are our payoffs, depending on the state of nature and the decision alternative that we chose. And all we did to find out the expected value for each item or for each decision was to take the payoff, multiply it by the state of nature, and then plus we would do the same thing for this payout for the same decision alternative and multiply it by the state of nature. Now I like to write everything out, and I know that we also like to put it in Excel, give you some practice with Excel so you have some practical skills when you leave the class. And we can do this either way, but for the sake of time, just because we're going to have to create the whole chart, I'd rather write it out so that you can see what we're doing, because this isn't really the key of what we're doing, but I just wanted to show you what the expected value is again, to remind you from the last video. Okay, and that's the expected value for small complex. Okay, and then you would do that for the other 2 decision alternatives, and actually we can just do that quickly here. Oh, it's going to be a little harder to calculate, but it should be 11.2 plus 1 is 12.2, and that's the expected value for medium. Okay, then we have 20 times 0.8 plus a negative 9 times 0.2. So 20 times 0.8 is 16 plus a negative 1.8 is 14.2. That's the expected value for a large complex. Okay, and we can see from there that this is our optimal expected value. So given the strong demand is 80% likely, or that's the probability, and then the weak demand is set at 20%, with these expected payouts, the large complex would be the best decision, because the strong demand, there's an 80% chance that you're going to get this payout as opposed to these other payouts. And then the 20% is weak enough where even the downside, because it's not likely to happen, it's not going to counteract the fact that these others do well in a weak environment. So the expected value overall, 14.2 for a large complex is the better decision here. So let's keep going. So that was the payoff table, right? So we just took the payoff table. Now we're looking at decision trees. And we're taking the exact same information and we're going to transform it into a decision tree. So over here, right, we just did the payoff table, just kind of a little review, just so you can see. That was expected value with perfect information from a payoff table. Now we're changing the payoff table and pushing it into a decision tree. And it's got the same information. See, it's got decision alternatives, small, medium, large, decision alternatives, small, medium, and large. It even says D1 for decision 1, decision 2, decision 3. And then we have our states of nature, right? Remember, strong demand is 0.8. So strong is 0.8, strong 0.8, strong 0.8. For each decision, small has a strong and a weak demand. Medium has a strong and a weak demand. Large decision has a strong and a weak demand. And it's that 0.8 and 0.2. They all have the 0.8 and 0.2, 0.8, 0.2. And they all have their payoffs. Remember, the 8 for a small, if the small decision, they have strong demand, had a payoff of 8. Remember, small decision, strong demand, had a payout of 8. It's the same exact thing here. I'll just arbitrarily pick large complex and strong demand, 20. Large complex, strong demand, which is the 0.8. Large demand, strong complex, payout of 20. There it is. So that's all it is. We've just brought this information and put it in its respective spots based on the state of nature and the payout. And, well, there's the decisions. Okay, I think that's pretty clear. So let's go to the next one. And there it is. It's a little cleaned up for you, a little bigger so you can see it. And, oh, went to the answers already. Okay, so what we want to do here is, remember how we did the expected value before? Let's get this out of the way. So expected value, again, we are going to take our payoff. Remember how our payoff table, we do 8 times 0.8 plus 7 times 0.2 to get the expected value for the small complex. That's what we did over here. 8 times 0.8, 7 times 0.2. We took it right from this table. So now we're going to do the same thing, but we're doing it from the tree. So we have 8 times 0.8, right? And we're adding, right? We add, because they're all from the same decision. They're all from the same decision. So 8 times 0.8 and 7 times 0.2. That's 6.4 plus 1.4. 4 is 7.8. And again, we took it all from the same decision. That's why we added it. Now we're going to do the same thing for one decision. And you'll notice, remember we said the circles. When you see a circle, that's when you think, oh, I have to do a calculation. And we're working from right to left. Okay, whenever you see a decision tree, you work from right to left. So we said 8 times 0.8 plus 7 times 0.2 because it's all part of one decision. And here's the calculation. So we add them together. We add this, well, we multiply this plus we multiply that, but we add it together to get one decision answer here. Or not one decision, but one calculation answer. Okay, we're going to do the same thing. So here we go, 14 times 0.8 plus 5 times 0.2. 14 times 0.8 is 11.2. 5 times 0.2 is 1. 12.2. And lastly, we're going to do the large decision. So we're looking at just the large decision. And we're going to do 20 times 0.8 plus, right? Because it's all part of the same decision or the same calculation to get an expected value. So 20 times 0.8 and negative 9 times 0.2. 16. And this is actually going to be a minus sign. Minus 1.8 is 14.2. And that is the optimal expected value of perfect information. And you can see that it is exactly the same answer that we got when we used the payoff table, because it's the exact same information. So it makes sense. The calculation nodes here, state of nature nodes, again, remember when you see circular, just think calculation. And then the square, that's when you make a decision. So we have our expected values, 7.8, 12.2, 14.2, and really what we would do here is we would write it right here, 14.2, 12.2, and 7.8. And then we would, so each one of them has, we've filled out the circle, right? We got to the circle with an answer. They all have an answer. 14.2, 12.2, 7.8. That's what the circle was about. Now, the next thing, we come up to a square, and that means make a decision. So we look at each one of our answers, and we make a decision. And obviously the decision is to go with the largest profit. So that's how that goes. So we've made our decision. Let's see how that looks here. So where are we? So that's us now. Okay. Oh, we're going to lose this information, but that's okay. I don't think we need it. No, I think we can let it go. So let's delete it so that we can and again, it's not really deleted because you can go back and actually see it in the video here. So you can just go back a minute and you'll see all the information appear again. So it's okay. So again, this is what we just did. 7.8, 12.2, 14.2. Because when we saw the circles, we knew we had to make a calculation. Remember, these were the payoffs. These were the states of nature. These were the decisions. So we got our answer, 7.8, 12.2, 14.2, and then once we had all the circles answered, right, we answered the calculation, then the next thing we came up to was a square, and the square means make a decision. So we had to either choose based on whatever the answer was for each circle. So we know that we wrote the answer 14.2, 12.2, and 7.8 next to each one of these, and they did the same thing. And they said, okay, well clearly we're going with the large, 14.2, that's the biggest expected value. And that's what they would do there. What is the expected value without perfect information? Okay, that's what we answered. Okay. So expected value with perfect information. So it's a little different, but it's the same thing as what we did with the tables. And let me see how far I want to go here. Okay, so this explains how to do it, and then this one will give you the answer. So let's just talk about it for a second. We'll walk through it. So remember with the table, when we did expected value without perfect information, without perfect, what we just did over here, we took the decision alternative, went left to right and said, okay, 8.8, 8 times 0.8 plus 7 times 0.2, and we got an expected value. Now, and that was without perfect information, because we just chose the decision and went with it. Now, expected value with perfect information means we're going to go top to bottom, and we're basing everything on strong demand and weak demand. So we're going to look at the strong demand and say, pick the one that's the biggest, right? Which one is going to give us the biggest payout? Because in theory, we're looking at with perfect information, we're saying, okay, if we knew it was going to be strong demand, which one would we pick? Clearly, we're going to pick that one. And if we knew it was weak demand, it was going to be weak demand, which one would we pick? Well, clearly that one, 7, not -9, because that's negative. 7 would be the one we'd pick. And then we'd multiply 20 times 0.8 plus 7 times 0.2, and that would be expected value with perfect information. So we're going to do the exact same thing. It's in table form, and it's in tree form now. I think, yeah, okay, so here we are. Don't want to get confused. So what is the expected value with perfect information? And actually, let's get the pen out here again. So we'll do this. We'll actually go back to the table because I think that worked nicely last time. Okay, expected value with perfect information. We look at the strongest, we look at the demand, the strong demand. We look at the states of nature. So we're going to look at strong demand, and we're going to choose the largest. Always a little tricky. Okay, expected value with perfect information. We're going to take 20 times 0.8, right? We're just picking the best. And then we're going to add 7 times 0.2. Right, we're going top to bottom. Okay, so if we continue with this, we get 16 plus 1.4, 17.4. And that is your expected value with perfect information. Remember, this is your expected value. This one over here was your expected value without perfect information. This one is expected value with perfect information. Okay, so let's show you how that works in a decision tree. Okay, and we're back. So let's go down to the decision tree. Again, you can see that there's not too much to this. It's the same thing, just getting you used to seeing the decision tree, not being worried by it or being confused by it. Everything has a process, so we're just showing you how it works. So again, just like with perfect information, we chose the best items for each state of nature. We looked at the state of nature first, and then we chose the best. So let's see what it says here. They actually give the steps. Find the best payoff for each state of nature. Okay. So for the point 8, right, if we look at just the point 8s, which one has the best payoff? 8, 14, or 20? Well, clearly 20 is the winner. So that's the one we're going with. Okay. And then let's find the state of nature. Well, the best payoff for each state of nature. So this is the other state of nature. And which one is the best payoff there? Right, it's the 7. So now we have our two state of natures taken care of. We have the best payoff for each. And now all we have to do is put it together, right? Because we see the circles here, so we have to make a calculation. So to make the calculation, we are going to choose exactly what we just looked for. And that's going to be the 20 times the 0.8, right? 20 and 0.8. And we're going to take the 7 and the 0.2. That gets us 16 plus 1.4 is 17.4. And that is your expected value of, or not of, let's not confuse everyone here. That's your expected value with perfect information. And you can see that it's exactly the same. 17.4, 17.4. So we know we did it right. So I stopped the video there just for a second so I could clean up a little bit here and make some space for the next part. So here's what we've done. We found the expected value with perfect information. We found the expected value without perfect information. So now we have to find expected value of perfect information. What's the value of knowing the state of nature before it happens? So let's just put a little bit of space there, or a line there, so we have a defined area. And we're going to do expected value with perfect information minus expected value without perfect information. And when we subtract it, we get the expected value of perfect information. So we know that this is 17.4, right, from 17.4, right next door here. Expected value with perfect information. And remember, this was all from the table, from the payoff table, and we showed the same thing finding it through the decision tree. But we're just doing the simple calculation here of expected value with perfect information, 17.4. Expected value without perfect information was 14.2, as you can see here, right? Expected value without perfect information. And when you subtract them, you get 3.2. That's how much your company would pay for perfect information. Okay. Expected value without perfect information, expected value with perfect information, expected value of perfect information. Okay, let's see what else we have here. I think we're going to have to clean up a little bit here. Expected value with, actually here, let's just clean this up quickly. That's the nice thing about the videos, you'll be able to see everything we've looked at so far. Okay, I think we got everything. So you're not really losing anything here, you'll always be able to see it. So expected value of perfect information equals expected value with perfect information minus expected value without perfect information. So that's exactly what we did over here. Expected value without perfect information, expected value with perfect, without, and then of perfect information. Okay. Let's move on from there. And this is the expected value of perfect information. It shows you. It didn't really have to do any calculations here. It just showed you quickly 17.4 minus 14.2 is 3.2. Okay, I think we've covered that, so let's keep going. And again, they wrote it out, but we already know. So decision analysis with sample information. This is so this will be the next part of. It gets a little trickier. It takes it to the next level of decision trees. But essentially, sample information is supposed to be extra or maybe newer information. Okay, most companies, whatever decisions they make, they have some type of information. Maybe they have sales from the past, or maybe they have some research analysis from the past. And at some point they say, okay, well, we need to renew our data, make sure that certain things are still in demand, or what's the current trend, that sort of thing. So they look for more information. There are market research companies out there that will call around, they'll follow data, trends, all these type of things, sales trends, so that they can sell this information to companies, and then companies can make better decisions and help their bottom line. So, okay, I guess that's a good enough introduction. Let's see what we have here. So, okay, so here's the problem. So assume that a management company, so this is the example that we're going into now. So assume the management company is considering a market research study designed to learn more about potential market acceptance of the project. Management anticipates that the market research study will provide one of the following two. Now, the key thing here is assume that management is considering a market research study. Everything that we're talking about here is just the idea of hiring this marketing company. They're not actually doing it. They're just considering the possibility of doing it. And because the whole idea of we want to figure out what the expected value of this sample information is, meaning, do we actually want to spend money on this market analysis? Is it worth it to us? Are we gonna, if we're gonna earn $200,000 extra profit, but we're gonna spend $1 million on this market research, obviously that's not worth it. So we don't want to figure this out afterward. We want to figure it out beforehand. So we have to make assumptions going into this to decide whether we're going to actually do this market research or not. So assume that management is considering a market research study designed to learn more about potential market acceptance of the project. Management anticipates that the market research study will provide one of the following two results. Favorable result or favorable report, a significant number of the individuals contacted express interest, and then an unfavorable report. Very few of the individuals contacted express interest. Okay. So your company, let's call it Development Corp, let's just call it your company, has developed the following branch probabilities. If the market research study is undertaken, we're assuming a favorable if. Now here's the thing, if the market research study, again, you're considering it, you're not actually doing it. You're not hiring the company to do anything yet. You're just considering the possibility. If the market research study is undertaken, a favorable report will be returned to you. Like you're expecting that the company is going to say, oh, there's a 77% chance after all the interviewing and focus groups, everything that we've done, we feel that 77% chance, your company is feeling there's a 77% chance that that market research company is going to come back with a favorable report. And then you're also saying then, therefore, that there's a 23% chance that after all the research that that market research company does, that they're going to come back with an unfavorable report saying that the demand is low. Let's say you sell jeans. Oh, maybe your jeans aren't in style anymore, or anything like that. So the next thing we look at would be if the market research report is favorable. Again, we're just considering things, but if the market research report is favorable, which we said is 77% chance, they're saying that, remember this, given F, given a favorable, the probability of a strong demand is going to be 0.94, 94%. So they're saying if the market research company were to come back with a favorable report, they're saying there's a 94% chance that there will be strong demand. And obviously, if it's a favorable report, they're saying there's a 6% chance that it's going to be weak demand. Okay? If market research is unfavorable, remember we said there's a 23% chance that the report would come back unfavorable. If the market research report is unfavorable, if it's unfavorable, given it's unfavorable, the probability that we'll have strong demand is 35%. So even if they come back with an unfavorable report saying, oh, we've contacted people, we did all these tests, and we've determined that your product isn't in style, or it isn't fashionable, or it isn't desired by a company, there's still a 35% chance that you're going to have strong demand even with an unfavorable report. However, with an unfavorable report, the reality is obviously they're not just making it up, because there's a 65% chance of weak demand, or at least you believe there is. You don't expect them to just make up this information. You would expect, with all the research that they do, that they're going to be able to find some truth out there. So, yeah, there's a 65% chance of weak demand. Okay, so if the market research study is not undertaken, the prior probabilities are applicable. So we're looking at a favorable report of 0.8 and unfavorable of 0.2. So let's keep going, see what we have here. Decision tree with sample information. So it looks daunting, I'm sure, and actually I don't think we need any of this anymore. So let's just get rid of that. Okay. So there we go. Maybe we can get a better look at it this way. Okay. And let's see where we're going with this. Right, okay. So the decision tree with sample information. Now, you remember what we just learned about this market research study. We know we're trying to determine whether we should even conduct the research. We know that there's a 77% chance it'll be favorable, a 23% chance it'll be unfavorable. And you'll notice, remember the squares, we have our decisions, we have our circles, which means calculations, and these are our same states of nature. State of nature 1, state of nature 2. State of nature 1, state of nature 2, just like the earlier problems we've had. And state of nature 1, state of nature 2 for each decision, right? It's exactly like the other problem that we had earlier, the other example. So what we've done here is, I don't want to mess with this too much, but the idea is the favorable, given it's favorable, what's the state of nature 1, state of nature 2 for each decision? So again, because we had the research study at 77% favorable and 23% unfavorable, we are given a different expected state of nature. For a favorable report, the state of nature is 94% likely that it's going to be a strong demand. Remember, this was strong demand and weak demand? Strong demand, weak demand. So if it's a favorable report, there's a 94% chance that this state of nature is going to happen. If it's a favorable report, there's only a 6% chance that the unfavorable is going, or the low demand is going to happen. So this favorable, and then that extra if, let's go back here so you see where I'm getting all this from. Remember, the favorable report, 77, and they said, okay, if research's study is undertaken, favorable report 77. If the market research report is favorable, so they're saying if you do the research, and if it comes back favorable, okay, it's 77. If the market research report is favorable, then the state of nature of strong demand is 94%. So first they're saying, before we didn't consider whether there was a market research study or not. We just said, is it strong demand or weak demand? Now we have to say, first of all, are we dealing with a favorable report or an unfavorable report? So we said, if favorable, strong demand will be 0.94. If favorable, weak demand will be 0.06. So it's the same thing here. Again, it's the same state of natures. And let me see if we can write it here just to remind everyone. S1 is strong demand. And actually, I think I can go off the page here. All right, yeah. And S2 is weak demand. Weak demand. Okay. And the F is favorable. So what they're doing here is essentially, right, we said there's a favorable report and an unfavorable. We're saying, so we're checking it under both ways. There's no real arrow there. So we're checking it, and this is a 9. Actually, let's clean that up. Again, I don't want any confusion. Perfect. Okay, so again, first we start with our favorables, and then we had unfavorables, because we don't know which we're going to get, so we had to check it under both situations. And then this is what we had before. Remember the 8, 7, 14, 5, 20, and 9. 20 and negative 9. Those are, so actually, let's see if we can go up here and show you. At the very beginning when we started out, remember we had 8, 14, 20, right? Strong demand of 0.8, weak demand of 0.2. So it's the same thing. It's a little sloppy there, but we have to get right back There we go. Now it looks more like where it should be. So this is with no research study done. We're just using the old information, the information we had before. And we're just going with that. So 0.8, 0.2, 0.8, 0.2. So I think that's pretty straightforward, right? We've just explained that we have the given a favorable report or an unfavorable report. We have to decide what the state of nature is for each one. So again, we said if it's a favorable report, we know that the state of nature is not 80, it's really 94. And given a favorable report, we know that the state of nature is not 20, it's really 0.6. And so we do the same thing for each one of these that had assuming a favorable report. Remember, if a favorable report, given a favorable report, then we have 0.94 and 0.6. And then for the unfavorable report, remember, favorable reports here, right? All the branches are above this line. All the decisions, 1, 2, and 3. And then we have the unfavorable report, and we have the decision 1, 2, and 3 with their state of natures. Okay. So again, with the unfavorable report, remember it said 0.3. Given an unfavorable report, the probability of S1 of a strong demand, right? S1, strong demand, is 0.35. And let's just show you so you can remember where we saw that. Okay, unfortunately it's a little messy here, but given an unfavorable report, the probability of strong demand is 0.35. Given unfavorable report, the new probability of weak demand is 0.65. So again, given an unfavorable report, the probability of strong demand goes from 0.35 rather than 0.8, because now you're saying the market research company saying, oh, beware, things aren't as good as you think. So it's not really an 80% chance of strong demand. It's really only a 35% chance of strong demand because you got this unfavorable report from the market research, or at least that's what you're expecting. If you were to expect an unfavorable report, you would expect the probability of strong demand only to be 0.35. The strong demand for whatever product you're selling would only be 35%. And I keep saying all this just to kind of, we're circling it and circling it, trying to say it in so many different ways so that you can kind of see where everything is coming from, and maybe at some point it'll click that, how it all comes together here. That, we're going from 0.8 to 0.35 because of this unfavorable report. So again, this is the strong demand 0.8. That was our normal. And then because we got the unfavorable, well, we haven't gotten it, but if we were to get an unfavorable report, we believe that strong demand would only be 35% chance of happening. And then if we got an unfavorable report, we would expect that the weak demand would have a 65% chance of happening. And then we do the same thing for each state of nature when using the unfavorable report. Okay, so again, the strong demand is always 0.35. The weak demand is 0.65 given these unfavorable reports. And again, the favorable reports had a 0.94 strong demand and a 0.6 weak demand given it was a favorable report. So it's not 0.8 for a strong demand. It's now 0.94 because you believe the market research company is going to say everything is great, go for it. And there's a 94% chance that it will be strong. That's your company's belief. Okay, and then once we've done this, and we have these numbers here, which they gave us all of this information, we just had to know how to plot it properly. Then all we have to do is our expected values. And let's see if they're going to do that for us. Oh, they do that for us. So instead of us writing it all out, let's just let's use the slides to our advantage. So expected value, and let me just see if this, okay, I think we can lose this now. We don't need that anymore, so we can, but I think it was important to have there so you can see exactly where the breakup was for everything. Okay. Okay. So the additional expected profit possible through the knowledge of the sample or survey information. And this is exactly like with perfect information and without perfect information. So expected value of sample information. And I just realized I left this up here. We don't need that. Okay. Okay, so here is the updated decision tree. They've done the calculations for us. Now, you would have to do this on the test yourself. But just since it's obvious what needs to be done, or at least we'll walk through what needs to be done, there's no reason for us to, or for me to write it out right now when it's much cleaner the way they've done it. So we have, if you remember, we had, let me actually go down one more and see if they have everything. Okay. So you can see here that, remember, our numbers were 8, 7. Those were our payoff numbers. 8, 7, 14, 5, 20, and -9. And we used the same payoff numbers, right? Because we still have the same payoff. We're expecting that the payoff will still be the same. And I'll go to the very beginning. We still have the same belief of how much payoff there will be based on whatever decision we make. It will still have the same payoff. Okay? It's just what's the likelihood of it happening is what that's what we've really been concerned with. This payoff amount hasn't changed at all. So let's go back here. So we have our same 8, 14, and 20, and 7, 5, and -9. And I'll keep flipping back between each. So you can see again, 8, 7, 14, 5, 20, and -9. 8, 7, 14, 5, 20, and -9. Again, for the unfavorable reports, the favorable reports, and then for our old reports, remember 8, 7, 14, 5, 20, and -9. So they're taking the same information from the payoff table. And we've done this all before already. And what they're doing is they're just doing the expected value with the new percentages. 0.94 and 0.06. 0.94, 0.06. So just to show you, I guess we can do a little bit of writing here. So we're going to do 0.94 times 8. We're going to do 0.6 times $7. And then we get this, and we add them together, and we get a whole number. So I don't mean that to be 8 plus 0. So let's clean that up, and then let's actually do the calculation. Actually, they have the calculation here, so let's go with theirs. So they have 0.94 times 8. Okay. We'll do it the hard way. So here we are. 0.94. Remember, if we're doing a calculation, it's 0.94 times 8 is 7.52. And then we have 0.6 times $7. 0.6 times 7. Or 0.06, sorry. 0.06 times 7. Remember, we did 0.94 times $8. Now we're doing 0.06 times $7. And again, you can rewind this if you're missing something here. And so we know that that's 0.42. 0.42. And if we add those together, we get 7.94. And that's the expected value for this decision, for decision 1. Remember, because when we see the circle, it means we make a calculation. We do a calculation, we do a calculation. So I'll do, I guess I'll run through these. We have time here, so we'll do it. And if you get this, you can fast forward through this a little bit. Okay, so let's do a few of these calculations. 0.94 times 14. So we have equal sign 0.94 times 14. It's 13.16. And then we have 0.6 times $5. 0.06 times 5 is 0.3. Okay, 0.3. Activate the pen. So it's 0.3, 0.30, however you like. That's 13.46. Again, that's the expected value. And that is 13.46. And lastly, we have 0.94 times 20. Equals 0.94 times 20. 18.8. And then we have 0.06 times negative 9. 0.06 times negative 9. Oh, forgot my equal sign. Always put the equal sign before formula. Okay, that's negative 0.54. So we have 18.8 18.8, and this was negative 0.54. Put that together, we have 18.26. And again, remember, this is all given a favorable report. Given favorable. So, and this is 18.26. So, if we look at that, we have 7.94, 13.46, and 8.26. Well, obviously we're going to choose the biggest one, and because the next node is a decision node, a square one, we're going to choose decision 3. That decision 1 was circled from before. So 18.26 is our decision. Decision 3, which is 18.26, and we bring the number along. So that's how that works, and we're going to do the same thing over here. So again, if you want to fast forward through, that's fine. So equals 0.35 times 8 equals 0.65 times 7. Okay, so I did 0.35 times 8, 0.35 times 8, and I did 0.65 times 7. And what we're going to do is add them together because they're all part of the same decision, right? Decision 1. We add all the states of nature together. Okay. So we have 2.8 and 4.55. Okay, equals 2.8 and 4.55. And that gets us 7.43. Hope there aren't any mistakes, or I'm going to have to clean this up later. So let's see, decision 2. We have to do the same thing there. So we have 0.35 times 14 equals 0.35 times 14 and 0.65 times 5. Right, 0.35 times 14, 0.65 times 5. We're going to add them together because they're part of the same decision. And this is the calculation. This tells us we need to make a calculation. So 0.65 times 5. 0.65 times 5, we did the equal sign, is 3.25. So 4.9 and 3.25. And that gets us to 8.15. And then we'll do the same thing for the last decision. 0.35 times 20. And 0.65 times negative 9. Negative 585. So let's put the information in here. Equal sign 7, equal sign negative 585. And then we add them together, and that gets us 1.15. Okay, and just reminding ourselves that this is the cutoff. Okay, looks good. So we have our numbers, right? So we have our calculations, so let's put them in here. 1.15, 8.15, and 7.43. Well, obviously we have a decision to make, so we're going to choose the biggest. So that's 8.15, decision 2. Okay, so now we have to figure out what the expected value is when not conducting a market research study. And actually, we have that information from before. I went and looked up the information so that we wouldn't have to write it all out since we already have the numbers. Okay, so it's all the same calculations, and maybe just to clean it up just a little bit so we don't confuse anyone. This is out here, expected value, 12.2 expected value, and 14.2 expected value. You know, we didn't do the calculation for each. I just wanted to save us time and space here. Okay, so again, we have a decision to make. We put the numbers in here, 14.2, 12.2, 7.8. We're going to choose the largest. We have a decision to make. We're going to choose the largest, 14.2, and that is decision 3. Wonderful. Okay, so I think pretty good so far, right? Straightforward. It's a little tricky sometimes, but nothing that you can't handle. I think we're getting the hang of this, and you can keep rewinding and maybe start over if you want to. Watch the video again just to get a second look at it and understanding it fully and knowing where you're going with it. But let's see. So, okay, so this was actually their calculator. I don't want to delete my stuff first. Let's just look ahead so they give all the explanation. Okay, so let's make sure we got the same numbers. 8.15 is what they got, 18.26 is what they got, and 14.20. So perfect. So we got everything that they got. And I think we can delete everything now. So we got a lot to erase, so let's use the big one. Okay. Okay, now we're looking good. So that's where we were. Expected value of sample information. So this is the breakout. So they showed us the calculations that they did. And we did the same thing. And I believe we got the same numbers. They all look familiar. They got the same expected value without perfect information. The same as we did. And so the next step, and this is the easy part, is once we got our 8.15 and our 18.26, all you have to do is do the expected value. Remember, we have a circle, which means do a calculation. So all we have to do is do 18.26 times 0.77 and add that to 8.15, and you're multiplying that. Let's just use this. We'll say that just so everyone understands. Times 0.23. So 18.26 times 0.77 plus 8.15 times 0.23. And we just got that from here, 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 and here. So we have, when we take the expected value of this equation, we get 15.93. That is, right, we did a calculation. We got 15.93. That's the answer to this. You can take the time to try it on your calculator, do it in Excel. I'm going to trust that it's accurate, and it looks accurate. And the reason that that looks accurate is 18.26, 77% more likely for it to be favorable than unfavorable. So 77%, 23%. So this was a more likely outcome. So we take the expected value of the equation, and we got 15.93. And then there's a decision to be made. And remember, we had 14.2. We have 15.93. So we say to ourselves, which one's the bigger one? And it's 15.93. So we have a winner, 15.93. So I just stopped the tape for a second there and wanted to show the solution and show that that's what we got there. We have the 15.93, and that's the expected value with sample information. Remember, the expected value without sample information. Remember, sample information just means getting the survey done. So, again, we were just considering it, but the idea of expected value with sample information is considering the survey information and assuming things played out. And then we have expected value without sample information, which was just the information we had before, right? The 0.8 and the 0.2 from our original payoff grid. So that's expected value without sample information. We just took expected values based on old figures of 0.8 and 0.2. We said we came up with newer figures, 0.94, 0.06, given a favorable situation, and given an unfavorable situation, assuming the market research would play out one way or another. We didn't know for sure. We didn't actually hire the company, but these are our estimates, or let's say our company's estimates of what the probability of certain states of nature would be. So considering the market research study, or the extra data, the newer data, is expected value with sample information. So we were able to, so that was an expected value of 15.93. So expected value without sample information, 14.2. And what is the expected value without sample information? That's correct, 14.2. What is expected value with sample information? Node 2, that is correct. And it shows you how the calculations, which we showed before. Okay. And what is expected value of sample information? Well, remember, of sample information is just taking with sample information and subtracting without sample information. With sample information, without. So it's 15.93 minus 14.2. Let's see if they do that. 15.93, right? Expected value with sample information. That was our 15.93. Expected value with sample information, right? Sample information means that we considered research, extra data. And expected value without sample information is 14.2. Okay, so it's just a quick subtraction. 1.73. What is the expected value of sample information? 1.73. Okay. So, and here's kind of a summary. Let's see what it says, or a review they call it. The expected value associated with the market research study is 15.93, right? The best expected value if the market research study is not undertaken is 14.2. So we can conclude that the difference, 1.73, is the expected value of sample information. That's everything we've said so far. And this is the key right here. This is why I read this whole thing, because I wanted to step by step and get to this last one. Therefore, conducting the market research study adds 1.73 million to the expected value. Okay. So, optimal decision strategy. So, conducting market research study, right? Do we conduct it or do we not? Well, we've determined that conducting it adds 1.73 million, right? 1.73 million to the expected value of whatever our business is. So, yes, it's a good idea for us to do the market research study. If the market research report is favorable, construct the large complex. If the market research report is unfavorable, construct the medium complex. So let's look at that second one. If the market research report is favorable, construct the large complex. So we're going to go back to the favorables. If the market research is favorable, construct the large complex. This was the large. So they're saying this is the best option. Let's see if that was true. Right, this was the favorable. Right, that was the largest. So they're saying if you, again, we haven't actually done the market research. We're just considering, our company's only considering the possibilities of what the market research company is going to give us as a result of their research. And what we're saying is, let's go back here. If the market research report is favorable, construct a large complex. If the market research report is favorable, right, this was the large, this is favorable. So if favorable, construct the large, because the large is 18.26. That's the largest expected value when a favorable report is given. If an unfavorable report is given, the best decision is going to be the medium factory. So that's also something else to consider. Okay. If the market research is unfavorable, construct the medium complex. Okay, because remember this was the favorables, so we picked the biggest favorable, which was large, and these were the unfavorables, unfavorable reports, right? Decision 1, 2, and 3. The largest was 8.15, and that's the medium. Okay. And lastly, we have the expected value of sample information, and really the efficiency of sample information. So what we're looking at here is just, we have these two figures already. We already know that the expected value of sample information, and in fact we just solved it, expected value of sample information is 1.73, right? We said that's the difference of expected value without sample, meaning not doing the research, and the expected value of getting the research. So what was the difference? 1.73. So that's what sample information, that's what the research did for us, gave us an extra 1.73. So with that extra 1.73, that's the expected value of sample information. And now we have to find the expected value of perfect information. Well, we had that from before, and let's see if we can find that slide quickly. There we go. Expected value of perfect information is 3.2. Remember, it was expected value with perfect information of 17.4. Expected value without perfect information, 14.2. So we subtracted the two. And again, expected value with perfect information was just finding the state of nature that had the best payout for each state of nature. So we found the state of nature, and we looked at the best payout for that state of nature, and then we found the best payout for that state of nature, and then we did the expected value. 7 times 0.2, 20 times 0.8, and we got 17.4. And so there we go. Expected value of perfect information is 3.2. Let's go back to the end here. And if, well, actually they probably have the calculation done. Using the EV of PI and EV of SI found in the previous slides, what is the efficiency? So, same thing. The efficiency of the survey, so they kind of draw it out here, but really it's just this simple right here. 1.73 divided by 3.2, and then multiply by 100, and you get 54.06% efficiency of SI. And that's it. That's the end. So we're all caught up on decision theory. We've gone through parts 1, 2, 3, and 4 in the slideshow. And that's it for this week. Okay, have a good week.